You want to find diamonds. Forget the shovel. Forget the metal detector. The real prospectors, the ones who find fortunes, are the ones who know how to read the language of roots and leaves. Because nature has already done the prospecting for you. And if you know what to look for, you'll never walk past a hidden diamond pipe again. Most people think plants have nothing to do with rocks. That's the myth that keeps them poor. But the truth is, every plant is a living chemical sensor, tuned to the minerals beneath its feet. Some of the world's richest diamond mines were discovered not by geologists, but by the silent work of roots and leaves. By the end of this video, you'll never look at a patch of weeds, a lonely tree, or even a termite mound the same way again. Let us start with the secret that built empires, the diamond plant, Pandanus candelabrum. At first glance, it looks like a mistake of nature. A palm-like tree with a thick, scarred trunk and a wild crown of spiny fronds. The real secret is at its base, a tangle of stilt roots as thick as a man's arm, radiating out like the legs of a giant spider. These roots do not just anchor the tree, they are nature's own drilling rig, reaching deep into the earth and pulling up water and minerals from far below. Here's the twist. This plant only grows on one kind of rock, Kimberlite, the volcanic pipe that brings diamonds from the mantle to the surface. But why does Pandanus candelabrum thrive where others fail? Because Kimberlite soils are loaded with magnesium, potassium, and phosphorus, the exact chemical cocktail this plant craves. Its stilt roots act like a living probe, tapping into nutrient-rich, alkaline soils that mark the hidden pipes of diamond-bearing rock. Where you see a grove of these trees, you are standing on a geological bullseye. Do not think this is just an African secret. The principle is universal. Across the world, plants have evolved to exploit the quirks of local geology. In North America, you will not find Pandanus candelabrum, but you will find other clues, grasses, and shrubs that thrive on magnesium-rich soils, or even the humble termite mound, built from earth hauled up from deep below and sometimes laced with kimberlite minerals. The lesson is simple. Nature leaves a trail if you know how to read it. So let us walk through the real-world countdown, the 5 botanical clues that can lead you to a diamond fortune. First, the ugly exterior, the stilt-rooted Pandanus candelabrum. In the swamps and forests of West Africa, it looks like a weed, growing in places where nothing else will take root. Inside it is a living map to buried treasure. The science is this: kimberlite pipes are born in violence, explosive eruptions that punch through the crust and carry diamonds and mantle minerals to the surface. The rock they leave behind is ultramafic, ultrapotassic, and loaded with rare earth elements. Over time, weather and rain break it down, creating soils with a chemical fingerprint unlike anything else, high in magnesium, potassium, phosphorus, and trace elements like chromium and nickel. Most plants cannot handle it, but the right species, like Pandanus candelabrum, turn that adversity into an advantage. How do you spot it? Look for a tree about 7 to 10 meters tall, with a stout trunk and a wild crown of spiny leaves. The stilt roots are unmistakable, thick and woody, radiating out from the base like the arms of a candelabrum. The fruit looks like a pineapple, turning from green to bright orange as it ripens. If you are in West Africa and you see this plant, you are standing on a geological anomaly. The value is clear. In 2013, Dr. Stephen Haggerty used this plant to pinpoint a kimberlite pipe in Liberia. The soil above the pipe yielded 4 diamonds during initial sampling, 2 in the 20-carat range and 2 in the 1-carat range. That is the kind of edge you get when you let nature do the heavy lifting. This is what nature hides from the impatient. But what if you are in North America? Here, the story gets even more interesting. The next clue is the leather oak, Quercus dorata. It is a small, gnarled shrub with leathery dark green leaves and a bushy, almost defiant appearance. It does not look like much, but it thrives on serpentine soils. Soils that, like Kimberlite, are rich in magnesium and heavy metals and low in nutrients. The science is this: these soils are chemically challenging, with high magnesium, low calcium, and often toxic levels of nickel and chromium. Most plants cannot survive. But leather oak has evolved to not just tolerate these conditions, but to exploit them. The protocol is simple. Look for patches of leather oak in California's coast ranges and Sierra Nevada foothills, especially where the surrounding vegetation is sparse or stunted. The value is clear. While not every patch of leather oak sits atop a diamond pipe, these plants are nature's way of flagging ultramafic rocks, prime hunting ground for Kimberlite. Sometimes the rarest treasures grow in the harshest soils. And then there is the whiteleaf manzanita, Arctostaphylos viscida. Picture an evergreen shrub, 1 to 5 meters tall, with smooth pale gray bark and clusters of white to pink urn-shaped flowers. It is a survivor, thriving on ultramafic soils in California and southern Oregon. The science is that, like leather oak, it is adapted to soils with high magnesium and low fertility, conditions also found in weathered Kimberlite regions. The protocol is to look for stands of manzanita on rocky, magnesium-rich hillsides, especially where other plants struggle. The value is clear. These shrubs are a living signal of mineral-rich ground. Where others see a wasteland, the prospector sees a signpost. But let's not forget the humble herb, Aster venustus. It is a perennial with showy, daisy-like flowers, usually purple or blue, and lance-shaped leaves. It is not flashy, but it is a survivor, growing in regions with ultramafic soils across North America and Eurasia. The science? Its tolerance for high magnesium and low calcium soils aligns with the chemical profile of weathered Kimberlite. The protocol? Look for patches of these flowers in otherwise barren or rocky ground. The value? In the right context, a field of asters can be a clue to hidden riches. The poetic power line. Sometimes the smallest bloom marks the greatest prize. And here is the wild card: termite mounds. They are not a plant, they are a phenomenon. In Africa, Australia, and parts of North America, termites build their mounds from subsoil material, sometimes hauling up Kimberlite indicator minerals from deep below. The science is simple. These mounds can concentrate minerals like ilmenite, chromite, garnet, and pyroxene, classic Kimberlite indicators. The protocol is straightforward. Look for robust plant communities growing on termite mounds, or break one open and look for heavy dark minerals. The value is real. In some cases, termite mounds have led prospectors straight to diamond pipes. Even the smallest architects can reveal the Earth's deepest secrets. But here's where the game changes. Modern mining companies are not just sending out geologists with hammers. They are using satellite imagery to scan for these botanical anomalies. Multispectral and hyperspectral satellites can detect the unique spectral signatures of indicator plants, mapping their distribution over vast, inaccessible terrain. AI and machine learning algorithms analyze these patterns, flagging clusters of Pandanus candelabrum or unusual vegetation as high-priority targets. The result is a sudden patch of green in the wrong place, a line of stilt-rooted trees, or even a pattern of termite mounds that can trigger a multi-million-dollar drilling campaign. Because when nature does the prospecting, the odds are in your favor. Let's talk value. The global diamond market is worth over $100 billion, with the average United States retail price for natural diamonds hovering around $4,400 per carat. But the real money is in the discovery. A single Kimberlite pipe can be worth millions, even billions, if it's diamondiferous. The cost of drilling a dry hole is tens of thousands of dollars. The cost of letting nature point the way is practically zero. In Liberia, the discovery of a single Pandanus candelabrum grove led to a kimberlite pipe that yielded diamonds worth hundreds of millions of dollars. In Canada, the Haggerty and Diavik mines, now among the world's richest, were found by following the trail of indicator minerals, glacial erratics, and anomalous plant communities. In Australia, satellite detection of vegetation anomalies over the Argyle Pipe led to one of the world's most productive diamond mines. So, how do you test your finds at home? Start with the basics. Document the plant species and the location. For soil, use a simple pH test, because kimberlite soils are alkaline and are usually above pH 7. For minerals, try a scratch test. Kimberlite is soft and is easily scratched by a knife. For indicator minerals, check specific gravity, because garnet and ilmenite are heavy for their size. Use a gold pan to concentrate heavy minerals from stream sediments. The real clues will stay in the pan, and if you are serious, send a sample to a laboratory for geochemical analysis. Sometimes a $50 test can reveal a $1 million secret, but do not get comfortable. The next clue is even more subtle. While Pandanus candelabrum is a showstopper, sometimes the best indicators are the ones everyone ignores. In the Canadian North, prospectors learned to follow the trail of glacial erratics, boulders carried by ice, dusted with kimberlite minerals, and surrounded by patches of hardy, magnesium-loving plants. The lesson? The landscape is a living map, and every plant is a signpost. And here is your ground truth protocol. If you find a patch of unusual plants, take a soil sample. Kimberlite soils are alkaline, rich in magnesium, and often have a soapy or slippery feel when wet. If you are near termite mounds, break one open and look for heavy dark minerals. These could be kimberlite indicator minerals, such as garnet or ilmenite. Use a hand lens to examine the minerals. Use a magnet to test for ilmenite, and use a field notebook to record your findings. Always check land ownership and legal access before you dig. In the United States, you can stake a mining claim on federal land after discovering a locatable mineral. You must mark the boundaries, file the paperwork, and perform annual work to maintain your claim. And always follow environmental laws, because nature rewards the patient, but punishes the careless. So, what is the real biological hack? It is this. Nature is the world's oldest prospector. Plants, microbes, and even termites have been sampling the Earth for millions of years, adapting to the quirks of local geology. The secret is learning to read their signals. Modern technology, satellite imagery, AI, geochemical analysis just amplifies what nature has already revealed. The biggest fortunes go to those who pay attention. If you want more locations, more trade secrets, and more ways to turn rocks into riches, subscribe now. The next clue could be hiding in your own backyard. Let us bring it home. The story of the diamond plant is the story of hidden fortune. A tree that looks like a weed, growing in a swamp, led to one of the richest diamond finds in Africa. The difference between a doorstop and a fortune is just knowledge. You now possess the secrets of a pro. The only question is, will you walk past your fortune, or will you know what to do?